Okay, so I'm gonna share my screen. Let's talk about Flex real quick. I'm gonna hide the video panel, and I'm gonna hide this. Okay, so for today, Wednesday, let's have a look here. Okay, so Brooke, you got Pantuso for Flex today. Let's see, Eduardo, you got Delgado. And then for Ariana, you got Brown. Am I reading the wrong day? You got Wednesday. Deal, you got Young. Okay. And then Emily, you have Shaw. Okay. So the Zoom information there. All right, guys. Questions on this? Brooke, it looks like you're flagged for tomorrow also. Just a heads up for Cobb. Okay. So there's Flex there. All right, guys. So for today in Schoology, if you've seen, got a new lesson today. It's a quadratic regressions, and what this does is that it calculates quadratic equations for you that you can use to make predictions with. All right, so we got some blank notes in there, and there's no video as you see, because what we're going to do is we're going to make the video right now using the Zoom. All right, so if you don't understand something, please ask me to stop and I can answer it, or you can refer to the Zoom video, which I'll put up right after this hour's up. Okay, so we're going to go over the examples in the notes here. If you want to get these up on a screen somewhere in a window to look at, we'll do these 3 examples together. Okay, then you'll need Desmos as well. So if you go to your resource folder, okay, you're going to need the Desmos calculator here. All right, guys, any questions so far? Trying to spill my coffee. All right, so let me put this forward so I can write on it better. Okay, so let's do this. So in our notes here, okay, so we're going to do example 1 together. So quadratic regressions, you're basically going to put we're going to make a table and put these values in. Okay, so here it has time and then height. Okay, so we have an amusement park ride, takes riders to the top of a tower and drops them. The table shows the height h of the tower at time t seconds after the drop. So we use x and y, okay, an xy table. X is your independent variable and y is your dependent variable. So you put an input for x and you get an output y. So since we have t and h, most of the time t is going to be your independent variable. So we'll use the t as our x and h as our y. Okay, so there's very few instances that time is a dependent variable. Time just tick, tick, tick. Okay, so as far as speaking physics terms, okay. So what we're going to do is going to put this table into Desmos. I'm going to show you how to do the regression. There's specific keys we're going to have to hit. Here is the walkthrough of another example here of how to get the regression. Okay, so we're going to do these steps here, but we're going to apply it to this example number 1. All right, so give you a few seconds to get your Desmos going. Take a sip of my coffee. Like a gulp. Okay, so let's do it. Okay, so first thing I'm going to do is, open the blank Desmos here, and then I'm going to go to this plus sign. All right, and then here we have some options here. So we're going to go to the table option. All right, so hit the plus sign, go to table. Okay, when you do that, before we start, you're going to notice that we have x1, y1. All right, and that references a certain table. Okay, so what we're going to do is on the y, notice it looks like the circle here is like a bowling ball thing. It's basically a scatter plot. So as we put a coordinate in, it's going to plot the xy coordinate of that point on your grid here. Okay, so that's what we're going to use. So for x, we've got 0, and we can go down the list. So we hit enter, we got 0.5. Then we have 1, then we have 1.5, and then we have 2. All right, and then I'm going to put in my y's, which is 200. Okay, and then we have 164. Then we have 120, and then 68, and 8. Okay. So basically, it should be scatter plotting here on the right. So as you're filling out the table, scatter plot isn't too useful here yet for us, but we do want to see it. I'm going to talk about a few things when we're looking at the scatter plot. So this is where domain and range comes into play here. Okay, so when we do the domain, that's a span of X numbers our function is eligible for. And when we do range, it's a span of Y numbers our function is eligible for. So if I look at my X values, we're going to have 0 as my small number all the way to 2. All right, so what I'm going to do is I'm going to make a window, because notice we don't see any points over here. I want to make a window where I can see these values. Okay, of course you can zoom out and stuff, but it's going to be very squished together because there isn't a lot of numbers between 0 and 2 here. And then here, if you look at your range on the Y, we have 8 as the smallest number all the way to like 200. So that's a lot of Y-axis. All right, so what I'm going to do is there's a wrench right here at the top. Okay, and I'm going to click that wrench. All right, and then go all the way down. You'll see X-axis and Y-axis. You can even add a label. So let's go ahead and put time for the X-axis. And then for the Y-axis, I can put the height. Okay, so let's put H-E-I-G-H-T. All right, I always mess up spelling of that. Okay, so then here you have an interval notation, not interval notation, in what's it called? Inequality form. Basically your domain and range. So remember, domain is the X-axis, and then your range is your Y-axis. So my domain is 1 to 2. So what I'm going to do is a good rule of thumb is you want to go a little bit lower than your smallest number, then a little bit higher than your biggest number. So I'm going to put -1 all the way to, let's say, 3. Okay. So I have -1 to 3, and you can already see it scaled over here. And then on my Y-axis, 8 to 200. So let's go ahead and just go ahead and say 0 here. And then let's do 210, something like that, a little bit over. Okay, so that way I have enough Y window. And then I can see right here, see how up here this is 210. If I didn't have the 10 up here, this dot would be right at the edge. So that's why I'm saying go a little bit above it, just so you have a good window to view it. All right, so now that I'm happy with my domain and range, my window settings, I can go ahead and click anywhere on the graph. And then I can see my dots. I have 1, 2, 3, 4, 5 coordinates. So I should have 5 dots, 1, 2, 3, 4, and 5. So those are the dots there. Okay, so what we're going to do is we're going to write the equation that fits this table here. Okay, so to do that, what I'm going to do is we're going to use the standard form of quadratics. All right, so here, if I hit the plus sign, I'm going to put a note. Okay, that means I can write text. So when I'm talking about quadratics, I'm going to use standard form. So we're going to have y equals ax squared. Let's see if I can do it this way. No, it won't let me use this at all. X squared plus bx plus c. Okay, so this little housetop thing, that means a power. Okay, so that means x squared. Okay, so here's our quadratic equation in standard form. All right, and this is the equation I'm going to use to do my regression. And it's going to look very similar to this. All right, so if I go back and I look at my notes, that's what we're using here, x squared. Okay, so to do the regression, the way you do it and tell Desmos to do it is you're going to put your y, but you have to reference that you want the y values from this table here. So when I put y, right after I type that, I'm going to type the number 1. It's automatically going to put a subscript. That means a number on the bottom. Okay, so look, it says 5 element list. That's because there's 5 numbers here. Okay, and instead of hitting equals, what I'm going to use is something called a tilde, or that's a symbol that looks like the ñ you would put over Trevino. In mathematics, it's the similar symbol. On most keyboards, it's on the top left side, and you have to use Shift usually to do it. But I'm going to show you here on the Desmos computer. If you go to your letters here, it's right here on the bottom. So that little squiggly line. All right, and that's going to tell the computer, so you're going to use that instead of equals, and that's what's going to tell Desmos that you're going to do a regression. Okay, and then I'm going to type in my standard form. So I'm going to put a, all right, and then x, But because it's x, we want to reference these numbers. We got to put the 1 underneath. So press the 1. Okay. So it subscripts it. And then I'm going to square it by using this button right there. Okay. Then I'm going to add the bx part. So plus sign, and use your b, and then x. Now this x, we got to subscript it with a 1 as well. There it is. And then plus c. And this is the hardest part of the whole thing. All right, no subscript here, only the y's and the x's. All right, so let me put this down. And there's our regression. All right, and you can kind of see our curve of our parabola going here. I taught you how to make that window, but if I actually zoom out a lot, move this over, there's my parabola. How cool is that? I know, too cool. Math is fun. All right, so it's asking me in the example to make the equation, right? So if you look at the example back here, there it is. All right, write the equation. Well, we'll do that in Desmos. All right, so our equation is going to be, and I'll just do it on the next line here. And you can write it down on paper because your homework is multiple choice, so you have to choose the correct equation. So this is basically what it is. So my equation is going to be y equals, and then what I'm going to do for my standard form is that it gives me the a, b, and c coefficients. So I'm going to replace a, b, and c with these numbers here. So I have y equals, a is a -16. Okay, I'm going to put x, and I'm going to square that x. Okay, then my b number is a -64, so I'm going to put -64x. Okay, and then my c number, which is a +200, plus 200. All right, and as you can see, this one's in red, and it's right over my regression line. So you know you did it right if you type this in and it matches up. So I can turn this off, I can turn this off, turn it on, and you see that they match right over it. Okay, and that's how you do a quadratic regression, guys. Next, any questions so far? Okay, let's do example 2. All right, so we see example 2 says Braden jumped off a cliff. Let's go over here. All right, Braden jumped off a cliff and into the ocean while vacationing in Hawaii. His height h after time t in seconds is given in the table below. All right, so here's our time. Again, we use this for x, and then we have a height, and we use that for y. Okay, so look at time 0, that's when he's on the cliff, right? Look how high he is already, 480, right? So then if you go 1 second later, he's 482. How is he higher than when he started? And then the numbers start to go down. So he's jumping off cliff, right? Anybody know? Well, that's because he jumped, right? So he jumped right off. So a little bit higher. I guess he has like about a 2-foot jump there. And then he started falling. All right, so we're going to write the equation the best fit. And then we're going to make a prediction. After 6 seconds, what will Braden's height be? And then after how many seconds will Braden land in the ocean? So we'll answer these 3 things using the Desmos, of course. So let's go ahead and do that. So what I'm going to do is I'm going to go ahead and click on these lines here. These 3 lines. It says untitled graph. There's some lines there. And I'm just going to put a new blank graph. Boom. All right. So let's go ahead and add our table, plus sign table. Do this other example. So I've got 0 to 4 in my x values. So I'm put 0, 1, 2, 3. And if it kind of recognizes your pattern, so they knew we wanted 4 here. I'm going to put my y values in. So I've got 480, then 482, 452, then 390. So it's very important that you pay attention to what you're typing and make sure your numbers match up. All right, so there is all my plots there. Okay. All right, so let's create a window, a little bit of domain and range practice so we can see it here. So go here. So this one here is going to be time again, so label that, and then this one here will be the height again. All right, height. All right. So time is 0 to 4. So let's do I'm gonna do -1 again, and then since it goes to 4, let's go to 5 seconds after. And then for my y-axis, so we're starting at 480 feet high. So when you think about our minimum, right, our less than part, so let's think of sea level, right? So when he hits the water, that's going to be 0. So let's do -10 again. All right, and then my height for my y-axis, we'll say 500, just because we're pretty close to it. All right, and then boom, there's my points. So here's my cliff, right? Jumping, 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 jumping. And then boom, we'll probably need a little bit more time here. So notice our question said after 6 seconds, and that's not a big deal. We'll just zoom out a little bit. Okay, but we can see our points right there. So it's a good starting window, time versus height. Okay, so let's do the regression now. So y, put your number 1. Okay, then you're going to put your tilde sign, and then you're going to follow your quadratic formula. All right, so you're going to put a, okay, x1, and then square that. Don't forget to square it. Oops. Okay, 1, there we go. Squared, there we go. Also, if you looked at my cursor, you see how it's still in the power. Be very careful that you arrow to the right and make sure it's not in the power there. Okay, so then plus bx, and then we need a subscript 1 again, and then plus c. All right. And then here we go. We got our a, we got our b, we got our c, right? Now remember what standard form c does. That's your y-intercept, right? And notice how it's at 480. So c is 480. That's your y-intercept there. So 0, 480. All right, so we weren't lying to you. Here it is applied to this problem. Okay, so then let's write our equation. If you write it correctly, it should match on top of this black curve with whatever color it turns out to be here. So let's write the equation. So y equals, our a is going to be a -16, okay, x squared. All right, our b is an 18, so we're going to plus 18x, and then c will be 480, so plus 480. All right, and as you can see, the red showed up right on top of our black curve. So we did the correct equation. All right, so answer some questions. So part B says, after 6 seconds, what will Braden's height be? So if we look down here, we're at 4 or 5 seconds. So we need to zoom out a little bit. And then if we look at 6, there's 6 seconds. We want to find out this height, okay? So what we can do is we can, to find out what that is exactly, we can put 6 into x here. So what I'm going to do is I'm going to delete the x, put a parentheses, and type in a 6 for everywhere there's an x. All right, and then it tells us right here, y equals 12. So after 6 seconds, he is 12 feet from hitting the water. All right, so it's just like putting that in by hand and typing in the calculator. There it is. So y equals 12. So here's 12 on the y-axis. There's the intersection. Bam. All right, so x is your time, y is your height. So 12 feet from hitting the water after 6 seconds. And then he wants to know, how many seconds will Braden land in the ocean? Okay, so let's take that into account. So what I'm going to do here is I'm going to delete the 6's and put the x back. Okay, you can leave the parentheses. It's not going to change anything with the parentheses there. Okay, so on this one, basically it's asking for the y. So we want to know when he's going to be at a height of 0. Remember, 0 is our height. So what I'm going to do is I'm going to change this y here, and I'm going to make it 0. All right, and then you see you have this vertical line. And again, here's the intersection. So this makes sense that it's right here on our x-axis, because that's what we take to be 0. So he's going to hit the water at just very fast after his the last question, right? At 6 seconds, we know he's 12 foot above the water. So he travels at 12 feet pretty fast in 0.069 of a second. So at 6.069, that's when he actually hits the water. Okay. All right, questions on that, guys? It's from the notes. So it's like part B. So after 6 seconds, okay, so remember seconds is our x, so we don't have a 6 on our table. So the whole point of doing these regressions is that we can make predictions. So after 6 seconds, we found out that he'd be about 12 feet above the water. Okay. And then we can be like, well, how long will it take him to hit the water? Well, okay, well, his height will be 0 at that point, and then we'll make y 0, and then we can figure out through the intersection that it's going to be at 6.069. All right, one more example, guys, and we'll call it for the lesson. So let's go back to the 3 lines, new blank graph. Okay, and then add a table. Okay, so for this one, let's look at these notes. Okay, car. A study compared the speed in miles per hour X and the average fuel economy in miles per gallon for cars. The results are shown in the table below. Yeah, I'd hate to see this for my truck. Okay, so study compared to the speed in miles per hour. So this is their speed X and their average fuel economy Y. Okay, so here's their fuel. Miles per gallon fuel economy is Y. Okay, so let's go ahead and make this scatter plot here and then put it into our decimals. So we're going to make the equation the best fit, and then we have answer B, predict the fuel economy for the car driving 35 miles per hour. So notice we don't have a 35 between 30 and 40. So that's where we're going to use that regression equation. We're going to find out to figure out what the fuel economy will be between going 35 miles per hour. All right, so that's how we use these regressions to make predictions. So let's do it. All right, so x-axis, we got 20. It goes by tens basically. Then 30, and look, see, it's already it's predicting I'm going by tens, so I need to go all the way to 70. So I'm just gonna keep hitting enter. Boom, pretty easy. Then let's put our y values in, which is 25.2. And then our next one, 28.5. Then 30.1. See, these are not pretty numbers. 30.4. 27.8. All right, double check your numbers. Make sure they match your paper. All right, looks good. Okay, so let's do, they'll see my plot, so let's go ahead and fix that using my wrench. All right, so my x-axis, they said is our miles per hour, so I'm gonna put mph. And then our x is our fuel economy. So I'm just gonna type fuel. Or is it F-U-E? There we go. So I got my fuel axis and I got my miles per hour. Okay, so we'll start at 20. So with mine, I'm gonna make the minimum. I'm gonna go ahead and just make it 0. Okay, and then I'm gonna go all the way to, let's go to 100 since we're going to 70, might as well. All right, so that's that's enough domain for us. So my fuel economy, let's start at 0 as well. So if we're not going any miles per hour, we should have like 0 fuel economy other than whatever your engine idles at. And then let's see, we got the biggest number here is about 30. Let's do 50. All right. Okay, so there is our window. Okay, 0 to 100 for X, 0 to 50 for my Y. And it looks like it's plenty of seeing. We can already see our parabola kind of taking shape here. All right, so let's do this regression. All right, so Y, okay, we've got to put a 1. All right, then we got to go to here and put in our tilde, okay, and then we're going to have a x subscript 1 squared plus b x subscript that with a 1 plus our c. Okay, so let's talk about this r number here. Okay, this r squared number. So basically, the closer to 1 this number is, tells you how well those scatter plots fit this equation. All right, if it's closer to 0, it's not going to fit at all. So there's two things that happens when it's close to 0. The scatter plot is like really random, or you chose the wrong equation. So remember how I talked about the 9 parent functions we're going to be learning throughout the year? Like quadratics is one of them. They have different shapes. So if you have a line, you know, if your scatter plot makes like a line shape, well, the parabola isn't going to work very well for it because it's a U shape. All right, so that's going to give you a bad R. This is your correlation coefficient. So it's going to give you a bad number for that. But since we can see it's kind of curved, it's a good fit. But it's not a perfect fit. It's really close, almost 99%, right? So if you can see, like if you look at these dots, they're a little bit off the parabola. This is like the best fitting parabola to kind of get most of the dots on the same part of it and try to keep them equal distance. The other ones we did had a 1, which means the other 2 examples, they were perfect, okay? This one, not so much. And most things you work on in the real world are not going to be perfect, but this is close enough, all right? And then here's the equation. And as you can see, there's a lot of decimals, right? So I'm going to use maybe like a couple of numbers of the decimals to do our equation. So let's use this equation. We'll model it this way. So we'll put y equals, all right, we've got our a number, which is a negative 0.00, let's put 8446, all right? Okay, so then I'm going to put my x, so that's my a value, and then I'm going to square that. Okay, then I'm going to do the b number, so then it's a positive, so plus 0. Let's see, 752. I'm going to round this 1 right here. Okay, x, and then we got a plus 13.5529. 0.55. Do we want to round it? It's not that many. 29. All right, good enough. All right, so it kind of fits on there. It's pretty close. It's going to be slightly off because I didn't use all the decimals, but there's probably not even enough pixels to even tell the difference. All right, but there it is, and that's the equation we'll use. All right, so let's see, what is the equation asking, right? This is, so there's our equation of best fit, and there's our equation. We'll write that down or choose that option from the homework. Predict the fuel economy for a car traveling 35 miles per hour. So basically what I'm going to do is I'm going to figure out where that is. So I'm going to replace the x with 35. All right, so 35, close that parentheses, and then replace this x with 35, parentheses, 35. All right, and our fuel economy is going to be about 29.5 miles per hour. So it kind of makes sense if you look at your range of data, so 29.5 or something like that. So that's between the 28 and the 30, so that's reasonable. Okay, so that would be my answer for part B. All right, and you can find that there at this intersection, right? Oh wait, this one, sorry. Not that one. All right, so at 35 miles per hour, close enough, about 29.5 miles per gallon of fuel economy. All righty, guys, any questions? All right, guys, so there's the Zoom. This is also the video lesson, and I'll be posting it there if you missed something at the end of the second period, because I have to close the meeting to do that. Okay, I would like to not see those things. All right, there we go.